All right, welcome to my video on solving absolute value inequalities. This is the second video, so we're going to do some examples. So, remember when we're solving these bad boys, we want to be isolating the absolute value. So I want to get the absolute value of x minus 1 by itself, all right? So the first thing I have to do is I have to move the 5 over. All right, doing so gives you 3 times the absolute value of x minus 1 is greater than or equal to 7. Then I have to divide by 3. And I get the absolute value of x minus 1 is greater than or equal to 7/3, which is like 3.5 if you're curious. Okay, so at this point, all right, we're saying greater than or equal to. So whenever it's greater than or equal to, that's a disjunction. So this is going to be or. Right? The reason being, we don't know what x minus 1 is, but we know that it's either more than 7/3 away from 0. Right? So here's 0. So 7/3 away from 0 would be here. That would be 7/3 away from 0. Or it would be here. All right? So anything less than 7/3 away from 0 would be all the way in here. That's not what we want. We want more than. So that would be all of these values and all of these values, right? Notice that's when, this is x minus 1, that's when x minus 1 is less than negative 7/3, right? Because all of these values are less than negative 7/3, and when it's more than 7/3. So remember, when you have the absolute value, in order to drop the absolute value, you do 1 exactly how it is, and then you do 1 where you change the direction of the inequality and you change the sign. All right. Then you solve for x. So I'm going to move the 1 over to solve for x. So x is greater than or equal to 7/3 plus 1. 1, that's 3 over 3, right? So this is 7/3 plus 3 over 3, which is 10/3. So we would say x is greater than or equal to 10/3. Or if we solve this one, so x is less than, if I had to move the 1 over, negative 7/3 plus 1. Remember, 1 is 3 over 3, so that's less than or equal to negative 4/3, because that's negative 7/3 plus 3 over 3. So it's less than 4/3, so it's or. So our answer is 10/3, or x is less than negative 4/3. So here we go. If we were doing our absolute value, this is 1. 4/3 is a little bit more than 1, so it's going to be like, kind of like right here. And we want less than or equal to. It's all of these numbers. And then 10/3, that's 3 1/3. Kind of like right here. So that would be all of those ones. So this would be negative 4/3, and this would be 10/3. So that would be the graph. We know it's an or because for or statements, it's always going to be 2 different segments on the number line. All right, here we go. So for this one, we want to isolate x plus 3, so we have to get rid of the 2. So we have 2 times x plus 3 is less than or equal to 4. I'm going to divide everything by 2. Divide everything by 2. So we get the absolute value of x plus 3 is less than 2. Now, less than, that is going to be and. Right? The reason being, we don't know what x plus 3 is, but we want it to be less than 2 units away from 0. So here's 0. 2 units from 0 over here. Right? And negative 2 is 2 units away from 0 in the other direction. So if we want the distance from 0 to be less than 2, we would want it all of these numbers. All right? Anything in here. Anything of there is less than 2 units away from 0. All right? Because they're both 2 units away. So that's how you know it's an and. Whenever it's less than, it's and. So we do 2 equations, same as before. You do 1 exactly how it is without the absolute value, and 1 where you change the direction and change the sign. Subtracting 3. That gets us x is less than -1, and x is greater than -5. And you could see, you could be both of those things at the same time, right? If I were to graph my solution set, right? This is -5. So greater than -5 is this way. And -1 is right here. So we have to be greater than -5, but less than -1. So that would be all of those values, right? It's greater than -5, but less than 1, right? So the way that you want to write it with an and statement is as one inequality, right? X. It's greater than, not equal to, greater than -5 and less than -1. And you're done. So just to review the rules for inequalities. So say we had an inequality like A is greater than B. So we want A to be greater than B. So say this is 0. If A is greater than B, we'll say this is B. If A is greater than B, it's on the right side. Now, all right, this has a length of B. Right, this has a length of B. And this has a length of A. All right, now if we reflect it, meaning we multiply by -1, all right, so this would be A is greater than B. If we reflect it, this is -B. And this is -A. And what you may notice is now A, what I want to do, now A is less than B because it's on the other side, right? So the same distance on the other side is the opposite, right? This is the unit of B. This is B, right? So I'm going to get rid of that, right? So what you can see is A is greater than B. If we change the sign, then what happens? Well, now -A is less than -B, right? So whenever you multiply by a negative number, also what we did, right? We multiplied both of these by a negative number. You reverse the sign. So multiplying or dividing by a negative number changes the sign of the inequality. Okay? So here we go. Solve this for x. So a lot of these ones want to tell me that this is a and statement because it's less than, but we have a -1 out in front. So before we determine if it's an and or an or, we have to isolate. We have to get it by itself. So the absolute value of x plus 5, when you divide by -1, that makes it greater than -4. So we want to know all the values that are greater than -5. So greater than, that's an or statement. So we're going to take 1, and we're going to make it greater than, or one exactly the same, one in which you change the sign. So if it's negative, it's positive. So this is when, solving for x by moving the 5 over, when x is greater than -9, or when x is less than -1. So either or, that will work. Okay, so here we go. Here's for this one. First things first is I want to divide by -2. Divide by -2. So x minus 1. I divided by a negative number, so I change the sign. Right? Change the direction of the inequality. -6 divided by -2 is +3. Now at this point, this is less than or equal to. So this is going to be less than or equal to is and. Alright? So x minus 1 is less than or equal to 3. Take 1 exactly how it is. And then I take 1 change the direction, and change the sign. Add 1. And get x is less than or equal to 4. And add 1. X is greater than or equal to negative 2. Can you be greater than or equal to negative 2 and less than 4 at the same time? Sure. If we were to graph that, it would look like this. Here's negative 2. I'm greater than or equal to negative 2. Here's 4 somewhere over here. We'll say this is 0, right? So you're greater than negative 2, but you're less than 4. So that would be your solution set. If I wanted to write it as a single inequality, which for and you do, x is greater than negative 2, but less than 4. There we go. All right, last one. So negative 2 times the absolute value of x plus 1 is greater than or equal to negative 4. So I divide by negative 2. That's a negative number. So I'm going to flip the sign. All right. Negative 4 divided by negative 2 is positive 2. Less than, that's and. So I know it's going to be x plus 1, exactly how it is. And 1, where you change the direction and you change the sign. X is less than 1, and x is greater than negative 3. So if we were to write this as a single inequality, it would be x greater than negative 3, but less than 1. Bam. And you're done.